Hello everyone, this is the video of the field trip to Red River Gorge / Natural Bridge area. So we just got off I-64 onto the Mountain Parkway. It's called the Burt Combs Mountain Parkway. And I've put a map of the physiographic map of Kentucky and the geologic map of Kentucky in this video, and you can refer back to that based upon what I'm getting ready to talk about. So when you leave the inner bluegrass region of Kentucky, and you can see that on the physiographic map, we're going to be traveling east to the eastern Kentucky coal fields. And throughout that region, throughout this drive, we're going to be going from rocks that are as old as close to 500 million. The oldest I know of are in the Clays Ferry Formation at 485 million years old, over through the knobs into the Appalachian Basin, also known as the Eastern Kentucky coal field if you look on the physiographic map. And the rocks there are as young as under 300 million years old. So we're spanning a geologic time of over 150 million years just traveling for about an hour out of Lexington into Eastern Kentucky, into the Gorge geologic region. So the reason that's the case, the reason there's such a large time span of geologic time in the rock record here is because of something referred to as the Cincinnati Arch. And the Cincinnati Arch is this large-scale anticline in the middle of central Kentucky that was created a long time ago with tectonic stress. So in central Kentucky, we have a geology that's referred to as Ordovician, and the types of rocks that you'll see there are limestone and shale for the most part. And this is the typical type of geography that you see here. It's pretty flat, inner bluegrass, rolling hills. You have sinkholes and that type of thing. And as we drive to the east, it will start getting a little bit more hilly, and we'll be going into the Mississippian and Pennsylvanian aged rock. So we're going from about as old as 485 million down to as young as under 300 million. And the types of rocks that you'll see as we approach the gorge and to the east of there are typically sandstone, shale. You may see a little bit of limestone as well. You'll see some conglomerate in the gorge, and coal if you go far enough east. So that's just a quick overview, a quick introduction to the physiographic regions of Kentucky and the geology of Kentucky as we travel east. Well, back in a bit. I just wanted to get a video of the view as we approach Red River Gorge and the Natural Bridge area. But I also wanted you to be thinking about something that I said just a minute ago, and that's talking about the age of the rocks as you go from central Kentucky to eastern Kentucky. I mentioned the reason for that is because you're traveling off of the Cincinnati Arch, but what I didn't really explain is exactly how that works, which will be talked about in this class. But I wanted to give you an illustration. This is probably a bad one, but it works. The Cincinnati Arch is this large-scale, what's referred to as anticline. And an anticline is a large-scale fold that's the result of continental collisions that occurred hundreds of millions of years ago. So let me put my notebook up here. As this fold erodes away from the top, just years and years and years of erosion, that exposes really old rock close to the surface. So you're looking at basically into the geologic past just by looking at the rocks in that region. Again, as old as close to 500 million years old. And as you travel to the east away from that, you're getting progressively younger as you get toward the Appalachian Basin or the Eastern Kentucky coal field. So I just wanted to explain that, and we'll see the gorge in just a bit. There are different ways to get to Natural Bridge, and one way is by the skylift. This is the first time I've taken it. Some cool features and quite a steep skylift, but a fun way to go. Alright, so we went the opposite way of where the bridge is, but I wanted to come over here and give you a view of what it looks like from the cliff, from the opposite way if you get off the sky lift, or if you keep going once you get up here. So that's the view of Natural Bridge. Next we will head over that way. Okay, so we're here at Natural Bridge. There are, as I mentioned, a variety of ways to get up here. This is one with the branch trail. There's other trails, and the sky lift, which we took this time. So this is a view from under it. This is one of, according to the Kentucky Geological Survey, about 300 arches in this area. The Red River Gorge / Natural Bridge area has over 700,000 acres of land, and it's kind of hard to get an appreciation for how big this one is from this side. I'll go to the other side in just a little bit, but this is in the Corbin sandstone. Again, moving from the inner bluegrass region to this type of geology is quite different. Sandstone with cross beds in it, and the way these things form, this is actually a divide, which we'll talk about in class. A divide between one watershed on that side of the hill and a watershed on this side of the hill. And they form by a process called jointing that's created by freeze and thaw. So when water gets in cracks, it expands about 9% and breaks off. So as you can see from this trail, this is a joint. So that broke away from that rock, and I'll post a picture of how that happens. But that happens over time, and you have these slabs that break off. And on this side of the hill, this is a drainage basin, so it erodes away at the bottom, and eventually becomes a natural arch. Now I also wanted to talk about the difference between a natural arch and a bridge. So there are lots of people coming. Most of these are actually natural arches, and when I said there were about 300, I'm including natural arches and natural bridges in that. So a natural bridge is actually a formation like this that has water running under it. This is actually just a natural arch, according to most people who study this sort of thing anyway. But we'll include both in those classifications. And there are lots of people who walk on top of this thing, so it certainly seems like a bridge. But anyway, just wanted to clarify that point. Some people have made the point that it should be called Natural Arch Park instead of Natural Bridge Park. But anyway, that's neither here nor there. All right, I'll go around to the other side and get some other views in just a minute. So this is the view from under the other side of the arch. You can take a closer look at the rock features. You see these little holes, and you see these little wavy lines, which are referred to cross bedding, and those form in streams. You see the iron looking stained, those are called Lysogang banding. Those are iron stained from iron rich water when this originally formed. It's pretty cool looking. And those little holes are just areas of less resistant material that it got eroded out more readily than the ones around it. You'll notice here that this is some conglomeratic sandstone. There's little pebbles, little quartz pebbles. From my reading, the conglomerates are about 90% quartz pebbles, from my understanding at least. From reading an AIPG field trip guide here from years ago. And usually conglomerates are the result of high energy environments. So you can think of a flood type environment, very large flood type environment around a large river, which many millions of years ago, this was what this is and how it originally, the rock types originally got deposited. And then more recently, you had the Red River, far down there somewhere, that actively eroded this entire area and caused steep cliffs and
Also, of course, the natural bridges and natural arches. You don't have a whole lot of caves in this area because most of the rock types are sandstone or conglomerate, and those rock types don't erode very easily. But there are some parts of the park that have limestone, and limestone can dissolve pretty easily, relatively easily geologically speaking, and can form sinkholes and caves and other types of karst features, which is talked about in this class later. There's actually a limestone arch here called Moonshiner's Arch, I believe is the name of it, which is kind of unusual to have something like that. But this is a very unique region. This is second or third, there's some debate about that from my reading and understanding as far as the number of natural arches in the world, or in the United States, excuse me. Second to Utah, second or third to Utah and Arizona. So if you've never been, this is an excellent place to visit. This is one of many things you can do in the Red River Gorge / Natural Bridge area. You could spend weeks in here and never see it all. Many of the arches are not public. There are not trails to them. They're a little bit more dangerous. These are the more quote-unquote commercial, if you will, trails, where it's easier to get to, and there's stairs and those sorts of things. The only downside to that is it can get, as you saw earlier, a little bit crowded sometimes. All right, that's all for now. I'll try to take some more on the way out.
I guess we're going to share a photo.
This is inside the joint or fracture as you're coming down off the top of the arch. This is the view from the top on the way back to the sky lift.
I'm standing, Debbie.
Heading back down.
All right, we left the natural bridge area and we are going into the gorge. This is Nada Tunnel. Some people call it Nada Tunnel. And this is largely known as the entrance into Red River Gorge. There are other ways to get in here. There's a different exit and such, but this is largely known as the way to get into the Red River Gorge geological area. And this tunnel was built in the early 1900s, I believe in 1911 if I'm not mistaken, as a way to get timber out of here before this was a national park. So this is a very cool area. We're gonna have one more stop, I believe, at a waterfall and talk a little bit about that in just a minute. Okay, this is the waterfall area I was referring to earlier. Just for reference, the road over here in the parking spot, if you want to pan around, this is just Pumpkin Bottom. It's just on the other side of the road, which is a few miles past the Glady Center. And as I mentioned earlier, these 2 or 3 stops that we've done are just scratching the surface. You could spend weeks out here and not do everything. But I at least wanted to stop by a few areas and of note and show you some cool things. So as you can see, there's a waterfall behind me here. There's also a hiking trail that goes up the other side of it. We'll go up there in a little bit and I'll show you some views from up above. But if you look around here to your right, you'll notice that there's some rocks. Let me walk around here. These rocks here are conglomerate.
And conglomerate are these rocks with these big pebbles in them. And this was the result of a very large, high-energy water flow situation a long, long time ago. Now, the rocks here at the bottom and the rocks here at the top, just to your left, are different. So there's a worldwide, maybe not a worldwide, but a large area in the United States that has what's known as the Mississippi and Pennsylvania unconformity, which occurred about 330-ish million years ago. So what happened here is you had these rocks that were laid down, and you had rocks that were laid down on top of it, which is over here to your left. You notice they look a little bit different over there. And the rocks that were laid down on top of these rocks built up over time, and they eroded away. So when they eroded away, more rocks got deposited on top of them. So there's I believe it's about a 40 million year gap in the rock history here. And that's referred to, when that happens, that's referred to as an unconformity. So here you have a very good example of that. As far as the amount of material that's missing, according to the studies that have been done from UK, about 300 to 400 feet of material is missing from this area. This area has been extensively studied by Dr. Frank Ettinson at UK, retired Professor Don Chestnut at UK, Tom Learman, he's passed away, taught at Eastern Kentucky University, and Charlie Mason at Moorhead, and many other people. So there are field trip guides written about this area, and it's just in addition to the cool science history behind it, there's obviously lots of stuff to do here as well. View of the waterfall from the trail on the other side, which goes straight up here above the waterfall. And then there's another little one up here we'll see in a second. Something worth noting here is how waterfalls form. So what you'll notice is the rock layer just below the waterfall there is different from the rock layer, the other rock layers below it. So usually what happens is you'll have a more resistant rock layer, and immediately under that you'll have a less resistant rock layer, and that less resistant rock layer is usually shale or something like that that erodes away pretty easily, while the overlying one tends to stay there for a long time. So all the stuff below it erodes away and leaves a waterfall. And waterfalls come and go. They don't last forever. Eventually that will erode away, and it'll be a different type of gradient here. The view from the top of the waterfall up here. Pretty much all these people down there. And a second waterfall. Quite cool back here. The ambient groundwater temperature in Kentucky is low 50s, low to mid 50s, so it stays cool in this little creek valley. And this is about as far as you can go up this trail. It's basically just a neat place to hang out, come visit, maybe take a nature shower.
Well, that's it. We're heading back to Lexington. We are heading back into the Cincinnati Arch. So as we're traveling west here, we're getting into older geology. So I hope you enjoyed the field trip.